Hey Ramblers, this video is going to cover something called the product rule. Now, we've looked at derivatives already, and we've seen that when we are adding two terms together and we take the derivative, we simply take the derivative of each term, like this. And so we'd get, if you took the derivative of x squared plus sine x, you'd simply take the derivative of each term. So you'd get 2x plus cosine x. And if we were subtracting terms, the same thing would happen. But what do we do when we're multiplying two functions? Is it as simple as just taking the derivative of each one and multiplying them together? Well, let's take a look. Suppose we looked at the derivative of x squared and considered it as the derivative of x times x. Well, if we did take the derivative of each term, that would just be the derivative of x times the derivative of x. And we all know that at this point, that's just 1 times 1, which equals 1. Now, that can't be right, because we know that the derivative of x squared doesn't equal 1. That equals 2x. So, since 2x doesn't equal 1, has to be wrong. So, there must be some other rule involved, and it's called the product rule. Let me show you what it is. If we're taking the derivative of two functions, in this case f of x and g of x, then we take the derivative of the first and you multiply it times the second, but then you add on the first function times the derivative of the second. So it's a little more complicated than just taking the derivative of each one. Let's look at an example. If we take the derivative of x squared times sine x, then we take the derivative of the first, which is 2x, times the second, so we don't change sine x at all. Then we add the first times the derivative of the second, which is cosine x. Why don't you try one? Why don't you pause the video and try taking the derivative of 3 to the x times x to the fourth. So pause it, do it on a scrap of paper, and then play the recording again, and I'll have the answer for you. Okay, you should have taken the derivative of 3x, which is just the natural log of 3 times 3 to the x, times x to the fourth, because the second function doesn't change. But then we add on the first function, which is just 3 to the x, times the derivative of the second function, which is 4x cubed. And we leave it like that. We're going to find that we don't have to simplify as much in calculus the way you did in earlier math classes. So, believe it or not, that's your answer. Try this one. Suppose you had the derivative of 3x squared times the natural log of x. Pause the video and see if you can figure it out on your own. Okay, we would take the derivative of the first function, which is going to be 6x, times the second function, which is natural log of x. And then we'll add the first function, 3x squared, times 1 over x. Now, it's usually good form that when the simplifying is this easy, that we should. So that becomes 6x times the natural log of x plus 3x, because this x squared and the x in the denominator cancel. So our final answer becomes that. Suppose we wanted to take the second derivative of this. Well, we would just take the derivative of 6x ln x plus 3x. So the second derivative would again involve the product rule here in the first term. So I would take the derivative of the first times the second plus the first times the derivative of the second. Oops, I'm sorry. This should just be an x. But then we still have to, so that's the derivative of the first term, but we still have to add on the derivative of 3x. So that becomes plus 3. So if we wanted to simplify, you just would have 6 ln x plus 6 plus 3, which of course would simplify to 6 ln x plus 9. Okay, Ramblers, that's how you do the product rule. and you're going to use it every time you run into a derivative that is the product, where you are taking the product of two functions. Okay, thanks for watching.